Assalamu alaikum, sir. Hello, everyone. My name is MD Mossaddeq Hossain. Our presentation topic is 555 timer. These are the name and IDs of my group members. This is the outline of our presentation. In 555 timer, I am going to talk about the trigger part. For that, we need to know about a stable and monostable mode. In a stable mode, the result of a 555 timer switches between the two unsteady states. Here, no outer trigger is needed for this. The component of the 555 timer can be used to produce non-stop rectangular wave. In monostable mode, the 555 timer has unstable state. At the point when the trigger is made low, the 555 timer switches into unsteady state. Then after a certain time, determined by the external combination of resistor and capacitor, the 555 timer returns to its steady state. Then we need to know about what is trigger. Trigger pin is used to provide a trigger to the circuit when the device will configure to behave like a monostable multivibrator. The pin 2 in the 555 timer is a trigger input. When the trigger input goes below the reference voltage on third VCC, the output of the timer is high and the timing interval begins. After that, we need to know about how does the 555 timer works. 555 timer is designed unusually to give a positive output through a control over its reset pin. Usually, the timer IC 555 timer is triggered by applying a negative going pulse to its trigger pin 2. This timer is triggered through a positive pulse in its reset pin. After that, when a voltage below on third VCC is applied to this pin, the output of the timer becomes high. The output remains high as long as the trigger terminal is held at low voltage. Now, my next group member will tell us about the threshold part.
Hello everyone, good morning. Today I will give a presentation on the topic of threshold. Let's start. So, what is the threshold or what is the concept of threshold? Threshold is a minimum point or minimum value below which the instrument doesn't work. This is an input to the upper comparator. This is the non-inverting input in terminal of comparator 1, which compare the voltage applied to the terminal with the reference voltage of 2/3 VCC. For more information, we can say that the amplitude of voltage applied to this terminal is responsible for the set state of flip-flop. Now we can see a figure. In this figure, there are 8 pins. So which pin is threshold? The answer is pin 6 is the threshold. When the output of the open collector discharges a capacitor between the intervals, then it toggles the output from high to low. In the next slide, we can see a more figure. In this figure, pin 6 threshold will be tested. In the circuit, we will take the source from pin 3, which is output. If we run the circuit, we will see that LED is off when where threshold is greater than 2/3 of supplied voltage. For more information, we can know threshold stop the timer. The timing interval is when the voltage at threshold is greater than that. At control, where 2/3 VCC if control is open. Thank you. I am finished here.
Hello sir, I'm Shamshu Tudor. In your presentation I have done the calculation part of duty cycle. So at first I want to tell about duty cycle. Duty cycle is the ratio of time and load or circuit is on compared to the time the load of or circuit is off. Duty cycle, sometimes called duty factor, is expressed as a percentage of on time. As 60% duty cycle is the signal that is on 60% of the time and of the other 40%. Duty cycle formula R1 plus R2 by R1 plus 2R2 into 100%. Now we move to the next slide. Here is calculation part. There determine the time period, high and low time, R2 and R1. Given that f equal to 200 Hz, this equal to 78%, C1 equal to 10 mu f. Time period equal to 1 by f. After that calculation 0.005 seconds. Time high and time low. Uh, Time high 0.78 into 0.005 second. After that calculation 3.9 millisecond. Uh, Time low 0.22 into 0.005 second. After that calculation 1.1 millisecond. Below of R2. Time low equal to 0.693 R2 C1. After that calculation R2 equal to 100 158.7 ohm. Below of R1. Mm, Time high equal to 0.693 C1 into R1 R2. After that calculation R1 equal to 404 into 1 ohm. That's all for me. Now my next member will continue the rest. Thank you.
Thank you, Sutradhar. Assalamu alaikum, sir. I am Muhammad Faisal Ahmad, and now I am going to talk about the simulation and the result part of our presentation. As we can see, we used a virtual 555 timer, two resistor, two capacitor, a VCC, a switch, two ground, and a oscilloscope for this simulation. At first, we kept the switch off. That's why we couldn't get any output. And then we turned on the switch. As a result, this type of waveforms will seen. If we change the time per division in high, then waveform should narrow, and if we change the time per division low, then it turn into white. Here the difference picture included. And if we turned it into two upper scale, it showed double waveforms in upper side. In that picture, we can see this. Finally, I want to go for the conclusion in our project presentation. 555 timer IC is used to generate a continuous output in the form of square wave, which turns the LED on and off. Here additionally going to calculate the capacity and varying capacity with the resistance capacitor. This project is calculating the pulse rate for the defining the frequency and time period. So that's all for our presentation, sir. Thank you, sir. Is there any question, sir?